Hello everyone, Assalamu alaikum. This is me, Abir Hasan Rohan, with my team. Today we will be talking about the project that we recently did, and our project name is an intelligent decision support system for DSC stocks using machine learning and news sentiment. So what we try to do here is every man in our country, almost 30% to 40% of the people in our country, they have invested a major amount of their capital into the stock market. But analyzing the stock market, analyzing the bar diagrams, analyzing how a stock market might move tomorrow, it's not that easy. And every other people has problem in understanding all this kind of matrix. In order to mitigate that problem, we have come up with a solution where we have used machine learning to study the news sentiments. That means whenever a news publishes, how it affects the markets, how the prices fluctuate in the next day. So based on our model, we will be able to predict the prices that we will get by analyzing the news. And then based on that news, we will be able to get a price range in which the price of the stock might fluctuate in the next day. Okay. Let's go through it. The abstract here is what I just explained. And for our research here, we have used 5 specific companies for analyzing. Among them, GP, Square Pharma, BRAC Bank, and Beximco are present. We have integrated the RSI system by using the moving averages, the volatility, along with the main topic, which is news sentiment, to get a synthetic data set for which we will be able to apply our models and then get the specific results. So the stock market, it encompasses a huge amount of wealth, and it has a lot of opportunities for investments. But when a person invests into it, there is a very limited amount of time in which he will be able to analyze it and then gain the profits from. So by observing the literatures that we have found online based on this topic, we have seen that most of the researches that have been done around this is to analyze the market itself, but not the prices. So whenever a researcher is researching about this topic, he's looking for the gaps in which the market can improve itself, but not the users. So in order to help the users get a proper gist or a proper grasp of the entirety of the topic, we have came up with this solution. Here, we have seen that most of the people who has studied the market have gone over through multiple artificial neural networks, which comprises of random forest, support vector machines, and different other long-term solutions. And whenever they're doing that, they have just gone through the data set of the stocks that they have used. For example, if I have used or if I'm using GP, then my preliminary tendency would be to predict the market by analyzing its share price before that date, or create an indicator by analyzing its previous years, which is effective in a sense. But whenever there is a certain news regarding GP, let's say GP has some sort of problem in its factories. So how will that news affect the market cap of GP? So we have done that, and we have done that by using 5 specific machine learning models, which are logistic regression, random forest classifier, a gradient boosting classifier, XGBoost classifier, and support vector machines. Here, we have used a certain data set which we have personally created to analyze all these models. The data set comprises of the shares that I have mentioned previously, and the features of those shares that has been included in the data set is the date, the trading date of the business, the code in which the identifies which the company gets its identifications, the opening price of the trading day, the highest price of the trading day, the lowest price of the trading day, the closing price of the trading day, and the volume of the share that has been traded here. Along with that, we have also collected corresponding newses of those days. So how does this help us? It helps us by uh, connecting all the features together, and we have implemented different models and different features. I'll get to that later. The dataset has been comprised of 2 years of data that we have found from the website of Dhaka Stock Exchange directly. And working through that, we will be creating our machine learning models. After we have created our machine learning models, we have seen significant rise in our accuracy compared to the accuracy that we have seen in other uh, research papers. For logistic regression, the accuracy stands up to 50.89%. And for random forest classifier, the accuracy goes up to 54.04%. For gradient boosting classifier, it goes to 50.69. For SVM, it goes to 51.48. And for XGBoost classifier, it's 48.52. Uh, the results might seem a little bit below the limit, because most of our research papers are generally done with an accuracy of 90 or 80%. But here, since we are just stepping up a little bit, the primary target of our research was to implement the new sentiment into the research, and taking all those on account, the efficiency of the models, it came up a little bit short than what we have expected, but it's better than most of the research papers that we have read before. Here, if you look into the graph itself, it's accuracy model for all the models, the model accuracy, the model F1 score, and the model ROC for EUC. Here, all of them and their accuracies have been mentioned clearly. So that's there. And how will this work for the final part? What this will do is, if we look into the graph for GP, we will be able to see that whenever there is a news, let's say a news came up here about GP gaining a substantial amount of customers in their next fiscal year. So what happened is, it suddenly went up to a higher amount. That means the shares that have been traded in the next day were significantly high. So we took that pattern and then we implemented that in our model. So what we have here is, let's say here in the mark where the red pen starts, if you look into that day, what happened was, let's say uh, in that day, GP had some sort of misinformation or some sort of mismanagement in their company, and the news came public. So what would happen is, in the next day, the market would be very likely to crash. And that's what we did. We created a system where we will be able to key or chalk down some specific words like low, fire, trouble, fired, under scrutiny, these kinds of words which are generally taken as negative indexes in the market news sentiment. We have sample of those words, and if any of the news has those words, then it would trigger automatic response for which the next prediction of the price would be generally going down. So that's what we did. And if there is no news, then it would be regarded as a neutral sentiment. And if there is some sort of bad news, it would go down. And if there is some sort of good news, it would go up. So that's pretty much it. And taking all of this into account, we have found out that we have ran multiple tests regarding the live news of of those share prices, and we have seen significant amount of similarities. So that's all. And no story ends with better, no better of the limitations, of course. So in our limitations, we see that since we have used old news data, and as the news community is evolving, there might be some sort of new indicators. Let's say, what if someone doesn't decide to use the word bad share for the market anymore? What if he uses something else which our indicators doesn't have limited into themselves? So it would be triggered as a neutral sentiment. So we will be working to that, and all of our model, it hovers around 50% accuracy, which is leaving us a room for further optimizations, which we will do. And there is a macroeconomic indicator limiter which doesn't allow us for getting a comprehensive understanding of the stock market. And since we are not being able to collect the global market data, it would like give us a lesser hand into that. So we will limit the better performing steps, and if we get those data, then we will be able to improve the settings a little bit more. So that's all for today. The references have been added here. Thank you for the time, all the honorable panel members. That's all.